This
Snowflake is a cloud
conference will now be recorded.
Snowflake is a cloud data warehouse. First, let me talk about the cloud. What is cloud? Here we have two things, right? On-premises and cloud. So what is the on-premises? If we are opting the on-premises, we means any organization opting the on-premises strategy to implement any IT department like that. So everything has to taken care by the organization. Everything in the sense buying the servers, setting up the servers, buying up the servers, setting installation, software installations, and a hardware installation, and networking. Like this, everything organization has to take care, even maintain the skill resources. Like this, so many activities has to organization has to perform as part of the on-premises infrastructure. In the same way, if we are opting the cloud, so what are the activities here organization is taking care? Everything is taken care by the cloud provider. We have the different cloud providers, popularly AWS, GCP, and Azure, Microsoft Azure. Okay, so here what we need to do is here upfront investment required. Here in the on-premises infrastructure, upfront means we need to do some investment. We in the sense again organization has to keep some upfront investment. Here no need of upfront investment. Here the paying model is pay as you go. Pay as you go, or also we can say pay as you use. So how much storage you are using, and what are the resources you are consuming, and what are the services you are utilizing. So accordingly, we need to pay for the cloud to the cloud provider. So this is overview about the cloud and on-premises. In the cloud, we have the three categories: IaaS, PaaS, and SaaS. IaaS means infrastructure as a service. Infrastructure as a service. So in this, if we are opting in this model, so only it provides that particular cloud provider provides the only infrastructure. On top of the infrastructure, organization has to build the platform, then software has to be installed on top of the platform, software tools to build their business applications. If we opt the organization opting this PaaS, platform as a service. If we are opting the platform as a service, automatically IaaS will be considered and PaaS will be considered. On top of that, what we need to do is SaaS. Means we need to install the software tools required CI/CD tools, whatever it is. On top of that, we can build our application for business requirement. Suppose if we are going for opting the SAS, software as a service. If we are opting this SAS category, then everything taken care by the cloud provider. It provides the infrastructure, it provides the platform, and it provides the software also. Directly we can focus to build our applications. Those applications can be web applications or mobile applications or IoT applications, even data warehouse applications also. So no need to worry about any installations, configurations, networking, nothing. Just we have to focus on to build our applications, to develop our applications. That is the advantage of the SAS category. Okay, this is about the cloud. Now our Snowflake is comes under the SAS category. That's what I'm trying to explain, these three categories. This is very important. Snowflake comes under the SAS, software as a service. We no need to bother about the any installations, configurations, network, nothing. Just we have to create the account and we can start building our data warehouse system. Okay, it's on the cloud. Okay, now coming to the other point is data warehouse here. Another point is data warehouse. Just I will give you a brief about the data warehouse. Later classes we can discuss in depth about the data warehouses. What is data warehouse? Again we have to discuss about the database. So what is the database and what is the data warehouse? Database is meant for OLTP transactions. OLTP means online transactional. Please don't bother about my spellings. I am poor in typing. So online transactional processing. Online transactional processing means here where we can store the data in the database, kind of structured data. And if we are building any web applications or any windows or whatever the applications, so those transactions, daily transactions or daily records will be, transactional records will be stored in the database. It will act as a backend database to any web applications or IoT applications or mobile applications. I'm talking about the RDBMSs. Coming to the data warehouse, this is also meant for store the data, but it will be stored OLAP. It is meant for OLAP, means online analytical processing. Online analytical processing. Online analytical processing. Transactional data will be stored in the database. Analytical data will be stored in the data warehouse. So whatever the data is available in the data warehouse system, it can be on-premises data warehouse or cloud data warehouse. It can be a Teradata, it can be a big data or Snowflake, Redshift, whatever it is. It will be useful for to do the analytical models, to prepare analytical models. And we can store the structured data, structured, semi-structured, and unstructured also in data warehouse. And always a data warehouse is a act as a single source of truth, single source of truth for data. Means in any organization we have the n number of applications in the organization. It can be a financial organization, insurance or manufacturing or healthcare, whatever the organization. So we have the n number of applications like sales applications, mainframes applications, CRM applications, ERP applications, web applications. So each application is having its own database and its own functionality. Suppose CRM application, it may have the CBL as a database or Oracle as a database, mainframes DB2 as a database. Suppose Java applications, SQL Server or Oracle as a database. Like that, we have a n different number of applications with the different sources of databases. So if anyone wants to extract and build the dashboards for the sales applications, they have to interact with the n number of databases, right? So to avoid that, if we are loading the data in the data warehouse, all sales applications, CRM applications data, mainframes application data, or procurement applications data, whatever the application data, everything is available in the data warehouse. So dashboard users or business users or analytical users can connect that to the data warehouses to extract the data, to pull the data to build their dashboards or analytical models. That's what we can say single source of truth for data for entire organization. So we will discuss more in detail about these concepts. and how we are pulling the data into the data warehouse from the different sources. And from the different sources means from different heterogeneous sources. Heterogeneous sources. It can be a DB2, it can be a DB2, or it can be a SQL server, it can be a SQL server, or it can be XML files, JSON files, whatever it is. So from heterogeneous to data warehouse. How we are pulling data into the data warehouse? Using the ETL. There is a mechanism called ETL framework. What is that? Extract, transformation, and loading. Extracting, transforming, and then load. So this tool will extract the data from the source and loading into the data warehouse. It can be any type of the source. It can be a XML file, JSON file, or CSV file, or DB2, MySQL, or Oracle, whatever it is. Now there is a, recently we have another framework called ELT. This is called extract, load, then transform. What is the difference? There is a difference and there are advantages in ELT mechanism. We will discuss in more details in our classes. Basically, this ELT mechanism is coming from the big data, means Hadoop. Hadoop onwards, we are using this ELT mechanism. In traditional data warehouse like SQL Server or this Teradata and MySQL, whatever the data warehouses are available on premises, we are using the ETL. But big data onwards, even in the cloud also, we are using the ELT mechanism. So these, by using these ELTs, we can pull the data from the different sources and loading into the data warehouse. We have the different cloud data. This is about the data warehouse. Now just I am trying, it's not 100%, I am trying to give an overview about the data warehouse. Now understand about the what is the cloud data warehouse. Now we will jump into the Snowflake. So Snowflake is a cloud based data warehouse. Cloud based data warehouse. So what are the other cloud data warehouses we have in the market? Different data warehouses, cloud based data warehouse. One is Snowflake, another one is Redshift, third one is Synapse, fourth one is BigQuery. These are the four data warehouses, cloud based data warehouses currently available in the market. Out of these four, we have the very unique features in the Snowflake. There are so many advantages. Architectural wise, we have unique features, and storage wise and retrieval wise. There are many advantages for in the Snowflake over the other data warehouses called Redshift, Synapse, and BigQuery. The one more advantage, one important advantage in the Snowflake is it can be deployed. It can be deployed in any cloud. Means any cloud means it can be Snowflake can be deployed in on AWS, Azure, or GCP. Google Cloud Platform from Google, Azure from Microsoft, AWS from Amazon. So it can be deployed on any three clouds. This is the one advantage, and there is architectural wise also Snowflake is having unique features. What are those? Just let me explain in the uh, pictorial representation. This is the architecture of the Snowflake. See, in the architecture, we have different layers. One is storage layer, and one is processing layer, Third one is services layer. Services layer. So each layer is having its own unique features and advantages. Let me explain you here. The storage layer is for storing the data. So here, what is the unique advantage while compared to other data warehouses is, suppose if you know big data hive database is there, right, in the Hadoop. So if you want to optimize the query or optimize the tables, we need to apply the micro partitions on the hive tables. We have to write the program to apply the micro partitions on each table. But whereas in the Snowflake, by default, Snowflake framework itself, it is providing the micro partitions. These micro partitions, to utilize these micro partitions, we no need to do anything, no need to configure, or no need to settings, nothing we have to do. Just it's already available by default, only we have to use that, that's all. Suppose if you are creating any particular table, so automatically it will micro partitions will be applicable to that particular created table. What are the advantages of that micro partition is, suppose if you are trying to extract the data from any particular table, suppose it is having millions of, suppose 10 or 20 or 100 millions of records the table has. To retrieve that, it is taking the time, right? So suppose if you are applying any filter conditions, instead of scanning entire table, it will go to that particular micro partitions and it fetch the data. So data will be stored in the form of micro partitions in the storage. That I will explain you with the examples also in our detailed classes. Just I am trying to give you overview here. This is about the storage layer. And coming to another layer is processing layer. This is very important and heart of the Snowflake. If you want to process anything, it can be a queries, it can be AI algorithms, or it can be ML algorithms, it can be data scientist algorithms, whatever the algorithms, whatever the queries you are trying to processing, query processing will take care of that. This query processing layer is having the virtual warehouse in the sense it provides the resource to do the computation. This virtual warehouse provides the resources to do the computation. If you want to do any computation or any processing, we need a system resources, right? Those resources can be handled by these virtual warehouses. These virtual warehouses available in the different sizes. It can be X small, small, medium, large, X large, like that. So based on our requirement, based on the size of the volume of the data, what we are processing, accordingly, we have to choose the size of the virtual warehouse. Suppose we are trying to process very huge table, it has having around 600 million records. Then we have to go for the extra large. If you are trying to processing just a 20 million records table or 20 million records data, then we can go for the just medium size warehouse. So there is a unique features are there in the virtual warehouse. We will discuss how to create programmatically, how to create through UI, and what are the parameters we need to consider in the optimization aspects or performance aspects, how we can handle virtual warehouse, everything we will discuss. Okay, now the another layer is cloud services. What is this cloud services means? So it is having the metadata manager. Metadata means every file, it can be a JSON file or CSV file, XML files, or tables, file formats. We have so many things in the Snowflake. Every file or every table or every pipe or every copy command, it's having its own metadata, data about the data. So those details will be handled by this metadata manager and optimizer, and it has giving the optimization of the query and security and access control authentication. So what are the objects can be accessed to the, what are the users, what are the roles can be accessed, what are the objects, how we are mapping the each object to the role and user. So all these things can be handled by this access control and authentication layer. So even we will discuss each one about here cloud services in detail. And one more point we can observe here in the services and query processing and storage layer, all three are in the decoupled manner. They are loosely coupled. Each layer is functioning independently. See, no connection between them. This is separate layer, this is separate layer, this is separate layer. All three are functioning independently or decoupled manner. This is the unique advantage and unique feature in the architecture, Snowflake architecture. Okay, now Snowflake is having the different editions. Different editions means we have the standard editions of the Snowflake, standard edition, business critical edition, enterprise edition, business critical edition, and VPS, virtual private software. So based on our requirement, we can choose the what edition we required. The standard edition is very high, lightweight version. So it doesn't have the much features and services. Whereas the enterprise edition is having all the Snowflake features. And business critical is having more than the enterprise edition. So we will discuss more about the what services are available enterprise edition and what services and features are available in the business critical. Coming to the last one, VPS, virtual private software, means if any organization, any financial or suppose organization wants to their own cloud, virtual private, so they can go for the VPS. So pricing is also differ from sorry, pricing is also varies from edition to edition. Charges will applicable as per the edition which you have chosen. Okay, just to practice ourselves, to make a hands-on experience to us to die as a developer, Snowflake provides the trial version. Snowflake provides the trial version for 30 days. 30 days. Once 30 days, after 30 days it has been expired, immediately we can re-register and we can recreate the account with the same email ID. Nothing to worry, it's very as simple as that. Just give the basic, very basic first name and last name, email ID, that's all. The same email ID you can repeatedly use to create the Snowflake version, Snowflake trial account. So there we can do our practice. We can make our hands dirty with the coding. Okay, let me tell you at a high level how to create Snowflake trial account. Just give your basic details. First name Sridhar, last name give some SF, email. My email is sfsridhar6 sfsridhar6 at the rate gmail.com. Company, give some company ABC, and role data engineer India. Just I am continue, before continue just I wanted to give some wrong email. Already I am having this account, currently. Just one, two, three. Okay, just I am continue. See here we can choose one of the edition, standard edition, enterprise edition, business critical edition. So here I am opting the enterprise edition. Standard edition we don't have some features to explain. That's what I am choosing the enterprise edition. It has the 90 days time travel, multi-cluster warehouse, materialized views, which are not available in this particular standard. So we will discuss in detail and coding also about these features. So let me choose the enterprise edition here and see, I already told you, right? So it can be deployed on any one of these clouds, Azure, GCP or AWS. So it is the one time activity. While we are creating the Snowflake account, we have to choose which cloud we are choosing. Later part we cannot change. So once we choose this, so the commercials are business between the Snowflake and this AWS or GCP, that we don't bother about. Internally, they will take care and it's their commercials. Okay, just we have to choose the AWS or GCP, one of them. I am choosing AWS. And region, which region we have to choose here. Better to nearby region to avoid the more latency, because Asia Pacific is near to us, right? That's what to India. That's what I have chosen here. Suppose if you are in the Europe, you can choose the nearby Europe, Paris or Europe, London or Ireland, whatever it is. You can choose anyone, but it is having the latency. So check terms and conditions, get started. See, you can give any training or certification, continue, or you can skip also, give some checkboxes or skip. I am skipping here. See, now one email will be sent to this particular one activation link will be sent to this particular email to confirm. So once we click that particular link, it will be confirmed and we are able to log in. So as I have given some wrong email, so I will not get the confirmation link. Now let me open my existing Snowflake account. Okay, username I'm giving and password, login. See, this is the UI, Snowflake UI. Okay, let me explain here to one thing. In the Snowflake, coming to the Snowflake UI, Snowflake interfaces, Snowflake UIs or interface, whatever it is, we have two. One is Snowside, another one is SnowSQL. SnowSQL. What is this SnowSide? Earlier we have another one, classic web UI console. Classic web UI. So classic web UI, SnowSite and SnowSQL. SnowSite is recently introduced with advanced features. Whatever the features available in the classic web UI, all features and advanced features available in the SnowSite. This NoSQL is the CLI, command line interface. So like who are having the favorites of the Linux, they will like very much NoSQL because it's a black screen. How we are writing our Linux or Unix commands, like that it will be appear. Now classic web UI is already just a few months back. It's a decommissioned. Now SnowSite is available. SnowSite is coming with the new feature called Snowpark. What is this Snowpark? So if we are storing the data in the Snowflake data warehouse, in previous projects, what we have done is to do the transformations or to do the processing, we are using the either DBT or Databricks on top of the Snowflake. But Snowflake now introduced called Snowpark. Underlying is it is using the Spark with Python, where Spark is the in-memory computation. We will discuss more details about the Spark also. This Snowpark feature not available in the classic web UI. Anyhow, it's a decommissioned. It's not available now. Now SnowSite and SnowSQL only available. This UI called SnowSite. This UI called SnowSite. So here we can create the SQL worksheet, this Python worksheet. This Python also inbuilt, this SnowSite is having inbuilt in as a Python. In earlier versions, Snow Classic Web UI, we don't have the Python worksheets. Okay, let me give you overview about the each component in the SnowSite. Very high level overview. Okay, this is the worksheets where we can write our code. For example, if you click the SQL worksheet, here we can write our code. Here I can write our code. Select star from some table name. Take this one. This is the database. Let me explain. This is the databases. So these are the databases. This Snowflake underscore sample underscore data will come by default with the Snowflake. Whenever you are creating the Snowflake account, this will be by default available. So we have the different schemas. Under that we have the each schema is having the tables. Under that tables we are having the different tables. Under that tables we are having the different table. Let me take this customer table here. Select star from this table. Okay, now let me execute. See here, just I wanted to give a one very good feature of the Snowflake. Now let me execute this one. Here I need to select. Okay, no need. Select it, run it. This is called SnowSQL, not SQL worksheet. It is getting executing. See, 15 million records. So it has this particular customer table. This is the table name. See, this is the table name. This is the schema name. This is the table. Sorry, this is the database name. This is the schema name. This is the table name. So this customer table is having the 15 million records. Okay. Now how much time it has been taken? 15 seconds. 15 seconds. 15 seconds. 15 seconds using the this warehouse. Let me execute this same query again. Here you can see the this dashboard also, query profile dashboard. See how it is taking, how so graphical representation we can see as part of the query profile. So how many tables are scanned and what are the partitions scanned, what is the disk size it has been scanned, and what is the total time it has been taken to execute, and what are the bytes scanned. See here what are the bytes scanned, scan progress, everything we can track here in the query profile. Even query details also we can see here. So how much time, what is the start time, end time, what warehouse we have used to execute this particular query, and what is the text and query text, what are the results, everything we can see here. See it, total duration is 15 seconds. Now let me execute one more time. See here, I am trying to execute one more time. This is the unique and beauty of the Snowflake. See How much time it has been taken now? 126 milliseconds. 126 milliseconds. First time it has been taken 15 seconds. Next time 126 milliseconds time it has been taken to retrieve the data for 15 million records. How it is happening? See here in the architecture virtual warehouse, see it provides the resources to do the execution, to do the computation of this particular customer table. It provides the resources. Each virtual warehouse it is having the cache here like this. Each virtual warehouse having its own cache. So first time whenever we are executing the query, any query, it what's the kind of query, it's a data scientist query, AI query, or machine learning query, or analytical query, whatever the query we are executing, first time it is the results will be stored in the cache. Very first time it will go to the particular Snowflake database and fetch the results and populate here. Next time onwards it will take the data results from the cache and populate to us, because first time it takes from database and store it in the cache. Next time onwards it will not go to the database, and instead of go there, and it picks the data from the cache. So that's what it is taking, that 126 milliseconds second time onwards. Like this, we have so many other features in the Snowflake. Why Snowflake is capturing more market than other data warehouses? These are the unique features. Anyhow, storing the data is possible anywhere. BigQuery can be stored, or Synopsys can be stored, or Redshift also we can store. But architectural wise, or processing wise, or um, computation wise, we have, and even cost wise also. And this warehouses, virtual warehouses, we have the two types. Means two types in the sense we have horizontal scaling and vertical scaling, and scale out, scale in, and scale up and scale down. We have the different combinations based on the scenario, when we are using the horizontal and when we are using the vertical, when we have to do scale up, when we have to scale in. So those scenarios and business use cases we will discuss. And this is about the worksheet. In the same way, we have the Python worksheets also here, where we can write our Python code. Suppose if you click Python worksheet, see this is the Python worksheet. Here we can write our Python code. Okay, now here see databases. Each database is having the structure. Database, under that database, this is the database name and this is the schema name. Under that schema, we have the tables. Under that tables, we have different number of different types of tables. And worksheets also we can see here. Okay, and this is about the databases and worksheets. See here data. See here all the databases available here. See database table definition and columns, preview, copy history, everything is available here. Okay, and coming here, admin. See, this is very important. Warehouses. Warehouses we have seen here, right? These are the virtual warehouses. Virtual warehouses, just we have seen. These virtual warehouses we can create here. Suppose if you see here, virtual warehouse, create virtual warehouse. Generally using the UI I am trying to create now. Generally in the real time we are creating these virtual warehouse programmatically. There is a syntax, I will explain you. Suppose if I am creating test123, this is the virtual warehouse name, and comment is optional. Here this is the size of the virtual warehouse. Based on our use case or based on the scenario, we can choose the size of the virtual warehouse: x small, small, medium, large, x large, like that. Okay, so these 2 credits per hour, this is the billing. These are the charges applicable to the each warehouse. How charges and prices, pricing model is applicable, how pricing model is getting executed, everything we will discuss. Suppose let me create, take the size is x small, comment optional, query access acceleration and multi-cluster warehouse. Multi-cluster, if you are choosing the multi-cluster warehouse, we have to give the min and max here. Auto scaling mode, min clusters, max clusters. Auto scale mode means, suppose if you are opting the auto scale mode here, so if you are not using the this particular warehouse, it will go automatically scaling based on the suppose data or volume of the data, it is scaling up automatically. And scaling policy, everything we will discuss. Okay, now create auto scaling mode, I am off here, multi create warehouse. See, test 123 has been created. The statistics we can see here. Test 123 warehouse and resources monitoring and users and roles. We can create the users and roles here, and programmatically, generally programmatically only we can create the users or roles. Basically here I wanted to explain one more thing. Snowflake is a RBAC, role based access control. So we do not give direct access to the user. It is not a user based, it is role based. If you want, if already few customer roles are there, default roles are there, on top of the default roles we can create the custom roles also. Let me show you the roles here. See, these are the roles: account admin role and organization admin role, public security admin role. These are the default roles coming from the Snowflake. This analyst full and analyst mask I have created for my previous batch. These are called the custom roles. So once we create the role, then those roles can be mapped to the users, not directly to the users. We can suppose if I want to give the access to the database access to the user, I cannot give the direct database access to the user. First I have to create the role. I can grant the privileges, database privileges, select privileges or query privileges to the role, and then I can map this particular role to the user. That's what we are calling it as a RBAC. This is a certification question. It is a user based or role based. Snowflake is a role based. Okay. Now, so we are having the security, billing terms, contacts, account, everything is here. So we can do, we will discuss everything. And one more important point is in the data. See, private sharing. Snowflake provides the sharing. Two types of sharing. One is this share. It can be shared to two types of users. Two types of users. One is Snowflake users, and another one is non-Snowflake users. What are these SF users, Snowflake users and non-Snowflake users? Suppose take any organization. Organization is having their own business partners or subsidiary organizations. Suppose I am having one organization. My organization wants to share particular data to my business partner. Suppose my business partner is using the Snowflake, then it is easy to me. I can share that particular data to my business partner. And in the same way, I want to share my data, particular data, not entire data, specific data, to another business partner or to another subsidiary organization. But that particular partner, business partner, not using the Snowflake. In that case also, Snowflake allows us to share the data to the business partner who is non-Snowflake user. It means that who is not utilizing or not opting the Snowflake. In such a way also we can share our data. There is a features are there, we can do that. Okay, this is the one feature and worksheets, everything we are discussing in detail in our regular classes. Okay, now what is our course content? Let me show what are the topics we will discuss. This is the course content what I am going to discuss in our regular classes. First, I am giving the overview about the database and data warehouse, and what is OLTP, OLEP, ETL versus ELT, and data warehouse concepts. Then cloud overview means I will explain about the what is GCP and AWS and Azure, and what is the advantages of the cloud, and what are the pros and cons of the on-premises. I will try to compare about the on-premises and the cloud data warehouse. Again, IAS, PIS, and SAS. And once this cloud overview is completed, I will jump into that introduction to the Snowflake, then Snowflake architecture. We will discuss in detail about the each layer and what are the components we are utilizing, and some components are we are not utilizing, but underlying it has the um, great functionality. Being a developer, we have to know the functionality of the each component. For example, micro partitions, we are not nothing we have to do, but underlying what it is doing, how functionality is happening. Being a Snowflake developer, we have to know. That's what I have introduced here, micro partitions, how it is happening underlying. So Snowflake trial version, editions, pricing model, and components of the Snowflake web UI. So as of now, just very few components we have a discussion right currently. As part of the we have very limited time. That's what I am not able to explain each and every component here. So we will discuss there here in the while discussing this particular topic. Then roles in the Snowflake. So we have the account admin role, organization admin role, or sysadmin role, and how to create programmatically, how to create, and how to create through UI, like that. Even we can create the custom roles also, and how to map to the users, how we are granting the privileges, means select privileges or write privileges to the particular role. Everything we will discuss as part of this roles topic. Then very important is Snowflake virtual warehouse. So this is the heart of the Snowflake. So what are the different sizes, how we are creating, what are the different parameters we need to consider while we are creating the virtual warehouse, and what is the multi-cluster warehouse. Well, multi-cluster virtual warehouse is to do the parallel processing, parallel competition. So how we are achieving that parallel competition, how we are creating the multi-cluster. Basically here what scenario we are using the multi-cluster in general, because simply if you are not that is not necessary. Also if you are using unnecessarily, it is the cost to the organization. So we have to know in which scenarios, in which business cases we have to enable this multi-cluster warehouse. That also we have to discuss. And Snowflake database, how to create the database using how to script. And we have the different data types in the Snowflake. So generally all primitive data types we will discuss as integer, string, varchar. But apart from that, it has the variant data type, means to store the JSON files or XML files or CSV files, we can use this variant data type for semi-structured, to store the semi-structured data. And we have the external stages, internal stages. External stages means cloud, internal stages means again within the Snowflake. So it is the very it plays very important role while loading into the data warehouse and loading into the different tables, and loading the CSV files, JSON files. And here I am covering two things. One is AWS cloud, one is Azure cloud. So how to load the data from the AWS cloud. So for that, I am showing what are the services we need to refer in the AWS, what is the purpose, and how to create the storage creation, identity creation, how we are creating the integration object. Integration object means the handshaking between the Snowflake and AWS. So to do that, we have to establish the connection between these two, right? To do that, we have to create the integration object. So how we are creating that programmatically, and how we are then, once object has been created, how we are pulling the data from AWS to Snowflake, everything we will discuss for AWS and Azure both. And also type of the tables, means we have the different types of permanent tables, transient tables. Tables are simple, very simple, but here important point is when we have to use which table. That is very important. Production, which tables better, and in the dev environment, what are the tables better. You can use permanent tables always, production, dev, anywhere, but that is not the correct way. So to optim in the cost perspective and the performance perspective, which table has to be used which place, that is the important, that we will discuss. And what are the pros and cons of the each table. And external table and views, we have the different views, non-materialized and materialized views, secure views, sequences for identity, Snowpipe for continuous loading. Generally, in the data warehouse, we have two types of loads, right? Batch or bulk loading, or continuous loading, means NRT, near real-time loading. So to achieve the near real-time loading, means continuous loading or streaming, we are using the Snowpipe. Generally, in suppose if I am in the big data Hadoop, I am using the Kafka to achieve the NRT, continuous loading. So here Snowflake provides the object named Snowpipe. Okay, that also how to create the integration and how we are achieving the Snowpipe, everything we will discuss. Clustering key, very important in the performance perspective, optimization perspective. Means already Snowflake provides the this multi-partition concept, micro-partition concept. So still, if you are looking for more optimization on top of the micro-partitions, you can apply the clustering key. So, and time travel, very important in the to capture the point in time snapshot, PIT. So if you want to capture the fast date, means suppose in 2002 data you have to capture. So particular point in time snapshot, suppose in the big data we have to create the frameworks and pit tables separately, and CDC columns we have to maintain, like that we have to achieve the time travel concept, point in time snapshot concept. But Snowflake provides the concept called time travel to achieve the point in time snapshot directly. And in the fail safe also for recovery mechanism. And we have the user defined functions, UDFs and UDTFs, tabular form. It returns the tables, zero copy cloning. And how to do the cloning, we can clone the database, we can clone the tables, we can clone the schemas. So all the objects we can clone it, even we can clone the roles also. So how we are doing, we can, why they are named called zero, means no, with no additional cost. Snowflake allows us to do the cloning without, with zero cost. That's what they are naming as a zero copy cloning. Now data sharing, see, as I explained you, with Snowflake users, with non-Snowflake users, stored procedures and tasks, basically to schedule, right? We can schedule the job, suppose frequency, based on the frequency requirement. So daily jobs or weekly jobs or hourly jobs, fortnight jobs, quarterly jobs. So in the others, earlier we are using the airflow on the AWS, otherwise on premises autosys or control m we are using. But Snowflake gives the default scheduling called tasks. And CDC, change data capturing, using the streaming and merging object. So if you want to capture the data, change data and any particular source table, we can achieve that CDC using these two concepts. And masking, suppose if you are working insurance or financial domain, you know the sensitive and non-sensitive data, P and PII data. So to handle the P and PII data, or sensitive and or non-sensitive data, we can achieve handle them by using the data masking. That also we see how programmatically we are doing and how we are achieving. So again, very important is Python. Here I did not mention that one Snowpark, because now from two batches onwards I am teaching Snowpark also, because it's a recent feature, very important feature. By using the Snowpark, we no need to go for the DBT or Databricks. That also we cover there. We are covering Python. We are using Snowpark allows us to write the programming either Python, Scala or Java. Here I am covering the Python. Here, before covering the Snowpark, I will explain the basic Python concepts. So what is the dictionaries, how to create, what operations we can do on the dictionary, and what operations we can do on the lists, and what operations on we can the sets, like that we will do. We will discuss all the API libraries, how to install it using the pip commands, very high level basics. I will explain the Python, then I will jump into the Snowpark. So I will not teach everything of the Python. What are the libraries required for this Snowpark or this Snowflake, that I will discuss and I will explain in detail. Then SnowSQL. This is the CLI command line user interface. This also we can. Once this is done, performance optimization and best practices. This is a interview prospective I have added here. Once this is about till this point about the Snowflake. Even if you are very good at Snowflake in the interview, if you are not able to speak about the data warehouse terminologies, if you don't know the data warehouse at least terminologies, it is very hard to clear or crack the interview. But it is easy if you are having these concepts or at least terminologies. If you are able to speak about them, it makes sure that you are having a hands-on experience in the data warehouse using the Snowflake. Not only Snowflake, any other data warehouse. That's what I have introduced, called this data warehouse concept. What is fact table? This is not about the Snowflake. This is about for any data warehouse, on-premise database or on cloud database, whatever it is. Fact table, what is fact, when we are using, what is the dimension tables, what is the star schema, Snowflake schema, what are the SCD types. We have three types. When in our projects, what type of SCD type we are using, what is the point in time snapshot, how we are utilizing, how we are achieving in the Snowflake, we will discuss in more detail. So by explaining them, it makes sure that you have a hands-on experience in the Snowflake in the data warehouse. And then technical roles in the Snowflake project as a developer, because as a developer, what are the things to be done, to be taken care in the daily. So by each story, by each sprint, in each sprint, what are the activities we have performed. Generally, suppose if you are migration from on-premises to the Snowflake, what are the documents we have to consider, what are the artifacts we have to consider, what are the mapping documents. So everything we will thus discuss in this migration. So migration process also, because now all the projects are migration projects only, from on-premises to the Snowflake or any BigQuery or Redshift to the Snowflake. So those migration projects only happening. So as part of the migration, what are the activities and what are the process and what are the stages, what are the artifacts we have to refer, everything we will discuss. And resume preparation and mock interviews. This is about my course content. And this is basically SQL basics are important. If you are everyone is okay in the batch, I am okay. If anyone not sure about the SQL basics, I will cover those SQL basics also. Not end-to-end SQL, whatever the required to this Snowflake, I will explain basics. Okay, this is about my Snowflake demo. Please proceed if you have any questions, doubts, please.
Hello, sir.
Yeah, please,
Hello.
Lokesh.
Yeah, sir,
Yes.
ఇది టోటల్ కోర్సు ఎన్ని డేస్ పడుతుంది సార్ డ్యూరేషన్?
Ah, actually, it's around 35 hours. around in plus or minus. Maybe if you are discussing more doubts or whatever it is, it may be 2 3 or whatever it is, but I am not very particular about the time period. So it can be extended plus or minus around 35 hours, I can say.
ఓకే. సార్ ఇప్పుడు స్నోఫ్లేక్ ఒక్కటే సరిపోతుందా? లేదా మనము ఏదైనా ఈటీఎల్ కాన్సెప్ట్ నేర్చుకోవాలా? లేదా ఏదైనా రిపోర్టింగ్ టూల్ గాని? అంటే బయట కొంతమంది అది కూడా ఉంటే యాడ్ అన్ అడ్వాంటేజ్ అంటున్నారు. కొంతమంది మ్యాండేటరీ అంటున్నారు. సో ఎట్లా అంటారు?
Okay, definitely. Suppose if you put the Power BI or a
ఆహా!
ClickSense or MicroStrategy, it's a added
ఆ!
value only. But suppose I am working big data almost 8 years. I worked 3 years on the Snowflake. These
ఓకే.
11 years earlier, I used to work on the other data warehouses and web applications. Okay, these years I know every even big data also MicroStrategy I have seen, and ClickView reports, ClickSense reports I have seen, but I never worked on that. That's a different separate teams are there. Even we
ఓకే.
don't have time to work on that, because that's a Power BI team itself a different location. So
ఓకే. ఓకే.
learning is not a part, but how many tools, ETL tools, again talent or informatica or so
హుహు.
many other cloud tools also there. But we have to know, at least in the interview, in the project architecture, while I am explaining for your resume, so I will tell
ఓకే.
you what are the tools you have to refer. Simply, I can say how you are pulling the data from source to the AWS using the talent. But I did
ఓకే.
not get a chance to work on the talent. I am the Snowflake developer.
ఓకే.
So that
ఓహ్!
way
సో
you can present, that way, Lokesh, you can present yourself as a Snowflake developer. If you say I am working, I used to work in the Power BI and talent also, definitely they will ask questions.
ఓకే. ఓకే సార్. అండర్‌స్టూడ్.
Okay.
యాహ్! యాహ్! ఫైన్. ఫైన్ సార్.
So I am not saying don't learn them, don't,
హ్మ్.
but
హ్మ్.
Snowflake, better to Snowflake only, because just you are going as a developer only, right? Even
యాహ్! సార్.
architect also, even I don't know end to end of the Power BI, but I know how it is connecting, how it is consuming the data. But building the dashboards, that is Power BI developer headache.
ఓకే. సో జస్ట్ ఓవర్‌వ్యూ ఉండాలి అంతే కదా సార్? డేటా ఎక్స్ట్రాక్ట్ చేయడం,
Exactly,
సోర్స్
exactly. Overview.
యాహ్!
See, this is the question. See, let me show you here. One second. Here somewhere I have explained. Here I will add that point. Ah, here Snowflake is extracting the data into the cloud data warehouse, and somewhere heterogeneous. Suppose here sources. Just take one any sources and sources into the cloud stage stage to Snowflake data warehouse. Here Snowflake data warehouse, we have different layers, analytical layer, presentation layers, whatever it is. Finally Snowflake data warehouse. From this Snowflake data warehouse, this reporting dashboards, reporting tools, sorry, business users, I can say business users will consume the data from the Snowflake using the reporting tool called Power BI or MicroStrategy or ClickView, like that. Okay,
ఓకే.
so you decide where source to stage, how, using the ETL. It can be a talent or it can be any other tools like that. So here we, our part is from here to here.
ఓకే సార్.
Okay, yeah.
ఓకే. సార్ ఇప్పుడు స్నో పార్క్ అనేది మనం మ్యాండేటరీగా నేర్చుకోవాలా? అడుగుతున్నారా?
uh,
లేదా ఓన్లీ స్నో
yeah.
సైట్ సరిపోతుందా?
uh, Earlier, now your question is just, we are we learning Power BI or MS ClickQ like that,
యాహ్!
right? Yeah, one year
ఎగ్జాక్ట్‌లీ.
back in the
హ్మ్. హ్మ్.
Snowflake, on top of the Snowflake, even for the two projects we have used Databricks
ఓకే.
for processing. One project for the DBT, total three projects. So now my current project, we are not using the Databricks or DBT. because now Snowpark is coming to the picture. Whatever the Databricks is doing, see here, Databricks is using the underlying Spark only.
Okay.
Snowpark is also using the Spark. So no need to learn Databricks now. If you learn the Snowpark, it's enough.
Okay.
But that Snowpark I will cover in my sessions.
Okay, sir.
Yeah. Any other?
Yeah, fine, fine, sir. Thank you.
Yeah, thanks.
Hello. Hello.
Yeah.
Hello. Hi, Lokesh
Yeah,
madam.
please.
Hi, madam. Hi, sir. Okay, sir. If the demo is completed, okay, then regarding this demo and other details, we'll call you and inform you after the session.
Sorry,
When is the session?
sorry, your name? Your voice is not clear to me.
Hi, sir. Hi, sir. I'm Chandana. I'm the
Your voice is
coordinator.
yeah.
Hello, sir. Are
Yeah.
you able to hear me?
Yeah, now it's okay.
Hello, sir.
Yeah, please go ahead.
Hello, sir. Are you able to hear me?
Yes, please go ahead. Yes, you are audible to me, Chandana. You are audible. You are audible to me. Please proceed. You are audible.
Yeah. Okay, then. Remaining details like when was the next class and what was there about the session, everything we'll discuss in after this session. We'll call you and discuss. Yeah.
Okay. Yeah, you are telling to the team, right? Okay.
Okay, if completed, we'll leave the session.
Yeah, just maybe I am asking them if there are any doubts. If no one is having any doubts or questions, we will wind up this session. Okay. Thank you all. Bye.